Hey there, Algebra 2 students. So today we need to continue on with our lessons in trig. And what we're going to talk about today is the standard position of angles on the coordinate plane. So before we really dive into our lesson, I'd like to do a little warm-up with you. And I'm going to help you get this warm-up set up. And then I'm going to ask that you kind of pause the video and finish the warm-up on your own, just to see how you do. So let's get started. The first thing we're going to do is we're actually going to plot the point that is the origin on our graph. And then we are going to, and I've just labeled it with an O, and O stands for origin. So if you recall, the point 0, 0 is the point of origin on all coordinate planes. Just a little reminder. And then we're going to make a blue arrow and a red arrow. So we're going to have a blue arrow, and this blue arrow is going to actually stay on the x-axis, pointing to the right on the positive x values. That arrow is going to stay there. And then we're going to make a red arrow that's just a little bit shorter so we can see the difference, and just put it on top. And that red arrow we're going to move around. So what you're going to do is you're going to take this red arrow and you are going to rotate it counterclockwise. So for example, you might rotate that red arrow counterclockwise so that it comes up off of the x-axis and is here instead. So what we've created here, I'm going to erase that red line, which apparently erases my blue line. There we go. We've created an angle by rotating that red line counterclockwise. And so what you guys are going to do is you're going to rotate that red line around the point of origin so that the red arrow goes through these points. And then you're going to tell me at which point do you think that the would have the greatest angle that's formed by those red and blue arrows. So go ahead and pause the video and start rotating that around, and then tell me what you think. So as you can see, I have added all the points. So I plotted 0, 1, 2, 2, negative 3, 3, negative 1, 0, and then 5, 0. And then I drew these dashed lines are just showing that my arrow rotated all the way until it got to the negative x values on the x-axis. And then what I notice is that these, the point of negative 1, 0 creates an 80-degree angle with our blue line and our red line. Oh, sorry, 180-degree angle. And so that angle is going to be the biggest angle out of all of these created. So through the point 50 right here, the red line would be creating a 0-degree angle with the blue line because it didn't rotate at all. Then through the point 22, we've got a 45-degree angle right here. Then the blue line with the red line going through 0, 1 creates a 90-degree angle. And then we create what looks like is about a 135-degree angle with the blue line and the point negative 3, 3. And then all the way down back to the x-axis again, we've created a 180-degree angle. So negative 1, 0 creates the largest angle with the red and blue arrows. So hopefully that agrees with what you found as well. All right, so let's start talking about some key terms. So we're going to have a bunch of key terms that we're going to talk about today. We're going to talk about standard position, initial side, terminal side, measure of the angle, positive angle, and negative angle. And we're going to talk about it as it relates to an angle that's created on the coordinate plane. So the standard position of an angle has a couple key parts. And the first key part is that the initial side of your standard position is always going to start at the origin and then be on the positive x value, part of the x-axis. And so this is always going to be what we call our initial side of our standard of our angle in standard position. Then the other side of the angle, so the terminal side, can rotate counterclockwise to any position, still starting with the origin, but to any position on the coordinate plane. So for example, I could rotate this terminal side so that it goes through quadrant 2. Or maybe I want the terminal side to go through quadrant 3. So what I have here is an angle that's been created by our initial side, and then this is what we call our terminal side. So an angle in standard position has an initial side and a terminal side. To have a positive angle, we always want to rotate counterclockwise. And if you rotate clockwise, then you're going to end up with a negative angle. So let's go ahead and define a couple things real quick. Let's talk about what standard position means. So an angle is in standard position when the vertex is on the origin. So our angle here, the initial side and the terminal side meet at this vertex, which is at the origin. So that fits our definition. And one ray is on the positive x-axis. Sorry about that. So a UPS driver dropped off a package, knocked on the door, and then our dog started freaking out, of course, because he's our little guard dog. So good job him. Let's get back into our definitions here. So we just talked about standard position, and then we also need to define initial side. So the initial side of the angle is always going to be the ray on the x-axis. So the ray on the positive x-axis, which we had labeled already. This is our initial side. Okay. Then we have what we call the terminal side. And that terminal side is the other ray that makes up the angle. So the terminal side is the side that rotates around the point of origin, and then wherever that side ends is what we call our terminal side. Then if we want to talk about the measure of the angle, so the measure of the angle, the measure of the angle is just the amount of rotation from the initial side to the terminal side. So the amount of the rotation from the initial side to the terminal side. So these are the keywords that we're going to be talking about all week. So the standard position of the angle, the initial side, the terminal side, and then how to find the measure of the angle. So the measure of this angle is the amount of rotation from our initial side to our terminal side. So it looks like we created an angle that is over 180 degrees, because if we had created an angle that would have been a straight line, that would be 180 degrees, right? If we had stopped on the positive y-axis up here, we would have created a 90-degree angle. If we would have stopped here, we would have created a 180-degree angle. And then if we had stopped on the negative y-axis, we would create a 270-degree angle. So this angle has to be between 180 and 270. And it's probably about, what, like 210 degrees, 220? And we're talking about the measure of the angle is from this this initial side all the way over here to our terminal side. So it's probably about like 220 degrees. Okay. So let's keep going. We need to talk about the difference between a positive angle and a negative angle. So a positive angle occurs when you have a counterclockwise rotation. Counterclockwise rotation. So for example, if we have a coordinate plane, here's our origin, and let's say on this plane we put our initial side here, of course, and our terminal side here. If we rotate counterclockwise, we would get a positive 120-degree angle. So if we want a negative angle, then we would rotate clockwise. So a negative angle is created when you do a clockwise rotation. Clockwise rotation. So let's put our initial side on the positive x-axis, where it goes. Our vertex is at the origin. And then let's rotate this direction 120 degrees. And we just created a negative 120-degree angle because we rotated clockwise instead of counterclockwise. All right, let's apply this information to some examples. So we're going to find the measure of each angle. So I have each angle already drawn for you. And we need to determine how many degrees these angles are. So when you talk about the measure of the angle, you want to make sure that you pay attention to whether or not the angle was rotated clockwise or counterclockwise. Because remember, counterclockwise is positive, and then clockwise is negative. So this angle has its initial side on the positive x-axis, just how we like it. And then the terminal side is on the positive y-axis. So this creates a perfectly right angle. And because we rotated counterclockwise, we have a positive 90-degree angle. So why don't you go ahead and give part B and C a shot on your own. Pause the video and then unpause it when you're ready to check your answer. So for part B, we have our initial side on our positive x-axis, just like normal. Our terminal side is over here, and it looks like we have a counterclockwise rotation. So what I notice is that if we had stopped our rotation here, we would have a 90-degree angle. If we had stopped our rotation here, we would have a 180-degree angle. And if we had stopped our rotation here, we would have a 270-degree rotation. Ooh, so what would it be if we had gone all the way back to our initial side and had our terminal side overlap? It'd give us a full 360-degree angle. Okay, but back to our problem at hand here. So it looks like this terminal side actually ended about halfway between 180 and 270. Well, 180 and 270 are 45 degrees apart, so I know that 180 plus 45 would be 225 degrees. So what I believe we have here is a 225-degree angle, and I'm just going to get rid of these extra markings because we don't need them. So this angle looks to me to be about 225 degrees. All right, and then part C. So our initial side is always starts at the origin and then goes along the positive x-axis, and our terminal side is here, and it looks like the terminal side rotated clockwise. So rotating clockwise gives me a negative angle. So we're gonna have a negative angle this time, and it looks like it has about the same placement as the one in part B did. So this is still going to be halfway between whatever this degree is, the y-axis, and the negative x-axis creates. So if you're going if you're going clockwise, clockwise would mean that, I'm going to switch colors here, that when we go from here, and if we had stopped here, that would be negative 90 degrees. Then here to here would be negative 180 degrees. And then if we continued that rotation and got to the positive y-axis, we would have a negative 270. And then back to the original positive x-axis, if we continued our rotation all the way full circle in the clockwise direction, we'd have a negative 360 degrees. So this time, it looks like our angle is halfway between negative 90 and negative 180 degrees. Well, I know negative 90 and negative 180 are still 90 degrees apart. Halfway of 90, or half of 90, sorry, would be 45. So what is 90 plus 45? 135. So what we have here is negative 135-degree angle. So I'm going to erase these extra pieces I added. And then I'm going to write my answer of a negative 135 degrees. So now we're going to sketch some angles in standard position. So instead of giving you the angles, this time you have to figure out where the angle needs to go based on the degrees. So I want to create a positive 36-degree angle. Here's my origin. My initial side is always going to go on that positive x-axis. And then let me think about where 36 degrees would be. So if this is 0 degrees, this is 90 degrees. I know what 36 is kind of close to 30. So I could actually count by like 30s between 0 and 90. So this, if I wanted to divide this into thirds, I would have, this would be my 30-degree angle, this would be 60, and this would be 90. So 36 6 degrees. And then if I wanted to cut between 0 and 90 and perfectly in half, I would go there, and that would be 45 degrees. So 36 needs to be between 30 and 45. And I'm going to go ahead and do this in purple. So 36 is probably going to be about right there. And now I'm going to go back and I'm going to erase these extra lines because I don't want my picture to be confusing. There we go. And we have drawn in I did not mean to erase that, a 36-degree angle. All right, go ahead and give part B and part C a shot. Pause the video, unpause it when you're ready to check your answers. Okay, so in part B, we want to create a 315-degree angle, positive angle, so we know we're going to rotate counterclockwise. I'm going to put the origin here. My initial side is always going to be on this x-axis. And then we need to rotate counterclockwise because it's positive. So if I stopped my angle here, I'm going to use black I would have a 90-degree angle. If I put my terminal side here, I would have 180 degrees. If I put my terminal side here, I'd have 270. And if we went all the way back to the initial side, we would have a total of 360 degrees. So 315 is between 270 and 360. If I wanted to divide this into thirds, because there are 90 degrees between 270 and 360, I know that I'm going to have 3/3 in between there. So I'm going to have so this part, this angle here, I'm going to erase. Well, no, actually I'm not. Okay. So if I went all the way around here, this would be 300. If I went to this terminal side, I'd have 330. And then if I went here, I'd have 360. So I know 315 is between 300 and 330. And it's actually exactly halfway in between. What's 45 plus 270? Of course, it's 315. So 315 is just perfectly in half between 270 and 360. So I'm going to erase all these extra lines that we created here because we should have known that halfway between 270 and 360 is 315. So that means that going counterclockwise from that initial side to our terminal side here, we have a 315-degree angle. All right. Now let's do negative 150. So negative 150, this one's the tricky one. We're still going to put our origin, our initial side, but this time we have a negative angle. So do we want to rotate clockwise or do we want to rotate counterclockwise? We want to rotate clockwise. So this time we're going to go that way. So where is negative 150 going to be? Well, if I rotated this angle and I put my terminal side here, this would be negative 90. And if I put my my terminal side here, so all the way this way, this would be negative 180. So I know that negative 150 is between negative 90 and negative 180. So I want my terminal side to end up somewhere in between here. All right, so let's see, how could we count between 90 and 180? Well, what's halfway between 90 and 180? I know that there's 90 degrees in between them. Half of 90 is 45, so 45 plus 90 is 135. So I would know that 135 is exactly halfway. But I wonder if I counted by 30s this time. So if I divided my 90 degrees, the 90-degree difference here, in 3, that would be 30 degrees. So if I divide this into thirds, what's 90 plus 30? It's 120. 120 plus 30 is 150. There we go. And then 150 plus 30 would be 180. So we found it. There's our negative 150-degree angle. So I'm going to go ahead and erase the rest of these so I don't get confused in my picture here. And we have found our negative 150-degree angle. All right. Have a good day. I'll see you guys tomorrow.